Oh, good. Yeah. All right. Last problem for today. Oh, my God. So now we know this. We know that u dot v equals the length of u, length of v, cosine theta, which also equals u1 v1 plus u2 v2, however big, however many dimensions you're in. Even if you're in 743 dimensions, you'll just go insane around 300, I think. So I'm not going to give you too many of those. So here's the beauty of this. I don't know, if you stop and think for a second, if I give you two vectors in three-dimensional space, finding the angle between them without doing what we're about to do would be just about impossible.
I was just going to ask earlier when you mentioned.
Got you. But now we've developed a way. Because this is always easy. This and this, always easy. That's the hard part, but now I can solve for it. Bam. Just inverse cosine, blah, 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 blah. So, if I have... oh, shit. Hear the way he described that. It was really... blah, 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 blah. And it just made so much sense. Sorry. All right, Jeff, so... let's see, -3, 5... well, sure, just stuff. There it is. Two vectors lying in three-dimensional space. Flying? No, that's why I don't teach English. Existing in three-dimensional space. All right, so this side is easy. All right. So what will you get? You'll get -3 minus 20 plus 3. So you get -20. Is that cool? That's the u1, v1, blah, blah, blah. That's supposed to equal, what's the length of u? 26, right? 1, 10, 26. Cool. So rad 26. That's the length of u. So is everybody with me here? This is the whole idea of math. Do this side this way, do that side that way, and then solve for the thing you don't know. I mean, that's what you always do in math. That's all we're doing right now. Length of this guy? 35. Times cosine theta. So then theta is going to equal the inverse cosine of -20 over this business. What's beautiful about the output of inverse cosine? Oh, shit. Where does the output of inverse cosine live? Between what and what? 0 and pop. Good. And what's beautiful about that is that's the extent of the angle I want to talk about. Because the minute it turns over here, it's still going to be between 0 and pi. Are you with me? That's the beautiful thing about inverse cosine. You guys gotta be careful about inverse trig and reference angles and bullshit here. No, inverse cosine is nice. That's why law of cosines doesn't have multiple possibilities, but law of sines does. Because the sine outputs were reference angles, the little jackass. Somebody got this in whatever, what do you got? Radians, degrees?
48.5 degrees.
48.5 degrees. So like 0.7, sure, like 0.75 radians. No.
It's not right.
Is it not? Look at me, trusting.
Oh.
Let me be quiet. Did you forget the negative?
Yeah.
So you got the other side.
Yeah.
So
all right.
2.29 radians.
2.29 radians.
And 131.5.
131.53.
53.
All right. Okay. So if you forget a negative, it's going to throw you in the first quadrant instead of the second quadrant, right? Okay. Cool. Yes, ma'am. The beautiful thing, what we're going to get into later is we already talked a little bit earlier than I meant to about how to define a line in 3 dimensions, right? You remember? In fact, I think it was 2 dimensions, but you can extend it to 3. Any 2 vectors. Let me say it this way. How many points do you need to define a line? 2. How many vectors do you need to define a plane? 2. As long as they're not like in the same, as long as they're not the same vector in a way, right? The minute I give you 2 vectors, they define a plane. It's just like the x and y axis. They define a plane. I don't even care if I do that at an angle. It still defines a plane. I forgot your question now, but remember that was part of the answer. Oh, you were worried about with reference to what? It's just with reference to each other in the plane that they exist in. Does that make sense? Okay, good. I like your question, but it's nowhere near that much to worry about. Okay. So you guys, real quick, you realize what we just did? We can't even draw this well, but we just found the angle between these 2 3-dimensional vectors. That was pretty good. All right, that's enough. Don't forget to, I forgot to do the field. We'll do that next week. Don't forget to do the survey online. I'll send you an email with a reminder. What happened? Oh, but you were here last time, right?
Yeah.
You're golden. Yeah, you're fine.
Okay, just checking.
Yeah.
Do you even take names?
No.
Oh, no.
You're good.
You didn't give us an app code last time, and you said it's going to be Wednesday.
Yep. So, sorry about the way. Just put your name and then write that down somewhere. Yeah. You need an ad code? Who else needs an ad code? You probably want to get that. Oh, thank you. Yay.